Hello. When I started learning R programming, I was largely attracted to coding because of most of the papers or journal articles that I came across. Some of the journal articles that really pulled me into using R and forgoing all other packages or programs that I was using before is this statement that all analysis and visualizations were done in R, and both code and data are available on GitHub. Now, analysis and visualization, when I looked at visualizations in some of these papers, they were very beautiful. I liked them. And because I liked them, and the analysis were using functions, I said to myself, this is the way I want all my studies to be. Like all my analysis and visualizations be done in one place. And then both the code and the data I use be available publicly to everybody on GitHub or whichever other platform is available there. So when I was stepping into R coding, I endeavored to have this sentence in most of my future papers for reproducibility of my work. And then I started using R, and if you look at my GitHub in 2020, December, that was when I started making commits and pushing to R to GitHub on a daily basis. In 2021, I made over 3,000 contributions. Like almost every day, I was writing some code and pushing them to GitHub for my future reference. Almost every day. I did the same in 2022, and I did the same in 2023. Those 3 years, I spent pushing code to GitHub because I wanted to master this and have all my programs and all my data and code be made available to everybody, because that's what drove me into R. Then in 2024, I didn't make much contributions to GitHub. And then in 2025, not much so far. Why is that? It was because in my learning curve for R, those 3 years were more than enough for me to learn R, especially for species distribution modeling purposes, and then start thinking about why. Why, in the sense that what am I trying to solve with these codes? And that took me back to this paper by Damaris Zurel and others, which was featured in Ecography, volume 43, where they give an explicit structure or framework of doing species distribution modeling in R. Specifically, I find it interesting that they made overview or conceptualization as the first step in any species distribution modeling workflow. So in that overview, they talk about what is the objective? What do you want to do? Which are the species, the taxon you want to analyze, the location, the predictor variables, the scale, and the concepts underpinning your model, software and codes and data availability comes. So this gave me a new thinking into species distribution modeling, which has nothing to do with being able to generate code in R, run the code and get a beautiful map. And this transisted into, first of all, taking your time to know why are you doing this species distribution modeling? What are you trying to solve? Do you want to introduce a new species to some location? Or do you want to look at areas where an invasive species is likely to colonize? Or is your interest to project into the future and see potential suitable habitat for a certain species, among others? So the underlying concepts or underpinning conceptual frameworks of what you want to do must be clear. If that is not clear, then data stage, model fitting stage, assessment stage, and prediction stage cannot be undertaken. So I'm making this clear because I know I'll be making some videos on species distribution modeling, and I want it to be clear that you should not really conduct species distribution modeling if you have no clear objective, clear taxon, clear conceptual underpinning your modeling, and also understanding of the codes and data you want to use. So that's why I reduced the rate at which I was pushing data into doing the coding side of it and came back to think about the underlying concepts, theories, hypotheses, the relationship between environment and organisms in a manner that when I bring in the tool like species distribution models, then it finds when it is grounded, whatever I'm doing is grounded on some established theories. Then data about biodiversity, how you partition environmental data, transfer data. We care, but less care is given into such. Model fitting, you must give them, state them clearly, but please, if there is no clear overview of what you're doing, then you are set to less success with this. I call upon everybody to check this paper and see what it takes to build a species distribution model. And that is supported by this statement. And this was a rejection of a paper I participated in its writing. Rejection is normal. If your paper has never been rejected, and I'm sorry, or you are super lucky, or I don't know. Our paper was rejected from a journal. I don't want to mention the name. And the editor, chief editor, mentioned that manuscript based on SDMs need to provide new methodological developments or highly relevant results for a broader readership. This broke the disconnect, or this broke the norm, actually the norm, where because there is a lot of data on GBIF or BN or IBAD or iNaturalist or whichever source, and these tools are now available in RSDM, ENM Eval, Wallace, and the rest. Somebody just bring occurrence records, environmental variables, build a model, have maps, send paper for publication. This was a rejected paper, and I'm happy that it was rejected because that is no longer the practice. The hype on producing maps, species distribution maps, habitat suitability maps is over. Now you need to tell the broader readership why this is really important. Either you are giving us a new methodological development in your SDM, something which builds on what we already know, and it builds significantly. Or you are just using the normal coding framework, but the results you are getting are super relevant for the broader readership. That is, everybody in the scientific community appreciates the work. If it is just this is an endangered species or critically endangered according to IUCN in this location, I grabbed these occurrence records from GBIF. I also walked into the field and collected occurrence records, went to herbarium, got some records, picked from RainBio, picked from BN, picked from IBAD, picked from this, cleaned, spatially thinned, build my model. This is the result. Ensembled the models. You make it sweet a bit. Yeah. Why? So anyone who is into species distribution modeling going forward, be prepared to have a broad overview of what you're doing before you start collecting data from whichever sources. Learn, basically, learn how to code. It's good for ecologists. I can't deny that. I think most of ecological journals now require that you supply both your code and data in a place, in a platform where people can access them, whether it's a node or Fig Tree or GitHub or whichever. So learn how to code in R. If you are an ecologist, I largely recommend it, but don't forget what defines an ecologist. And that is based on theories, hypotheses, research questions, the objectives, the concepts behind what you really want to do. That is more important than hitting the keyboard and getting a map. If you have a sound theory or a broad or a clear objective or underpinning concepts, then results or the habitat suitability map or binary maps or which threshold criteria you use to binarize your map will all make sense and develop a clear storyline for everybody. Many young ecologists are good in R, while their supervisors or professors may be less proficient in R or coding. Whatever they say, these professors or supervisors tell you, please pay attention to it. Don't just run into coding. before you have a clear overview of your species. Sometimes it may not even be necessary to build a species distribution model to address your hypothesis or your question in the first place. So only when you have clear overview and concepts, objectives is when you are free to proceed with your modeling. And just to show you one more thing, is that the ODMAP I shared, which is overview, data modeling, assessment, and prediction, is on the web. You can find it if you search this link. You can find it, and it can help you to fill in this form, which in the end you can download. And once you download it, you can even attach it and as an appendix, or it can really help guide you on what you've covered and what you've not covered in building your species distribution model. So thank you. I hope this information will help an ecologist out there struggling with species distribution modeling, especially on where to put more emphasis. Learning R is important, but the theories and concepts behind what you're doing are more important. Thank you.